So hello everyone, welcome back to our channel. So in this video we will be solving another LeetCode problem, that is LeetCode 1110, delete nodes and return forest. So in this problem we are given a tree here and along with that to remove array. So what this problem statement says, that we have to remove these nodes and then we have to return a list of forest. Forest is simply a bunch of subtrees. Like for example, I'll tell we have to remove first 7. So if I will remove 7 over here, I will remove 7, but they will be present this 8 and 9. So I will store this 8 and 9 in that array. I will return 8 and 9. Okay, so now this 7 is removed. Now this particular is not a part of this tree, entire tree. Now next we have to delete 10. I'll remove 10 and check whether I have a left or a right subtree. No, there is no left or right, then ignore it. Now the tree becomes this, right? Now we have to remove 2. To remove 2, we'll remove this connection over here, and since it has a left and a right subtree, I will store this as well as these two subtrees in the list. So that's what we'll return. We'll remove this first. We'll remove 7. So we'll see I have these two subtrees. I'll return this 8, 9, right? Then after removing this 10, there's no subtrees in the left and right. Then for removing 2, we have these two left and right subtree. I'll store this 3, 4. Then we have 5. So this is a forest, like collection of trees is called a forest. So this is the answer for this. Now we'll write the code for this and then we'll do a quick dry run for better understanding. Okay, so before jumping to the code, I remembered one important point, or an edge case, I can say edge case, that what if I have this array, to remove array as previously it was 7, 10, 2. What if I had additionally 3 in this? Okay, now I will try to implement this. I'll remove 7. Okay, I'll store the left and right subtree. Okay, I've stored it. Now next I'll remove 10. There's no left right subtree, ignore it. What next? I have to remove 2. I'll remove 2 and then store this 3 and 4. Then we have 5. Okay, but one important thing, after removing this 2, what is left in the tree? That only 1 and 6 node is left in the tree. Now I have to remove this 3, but I cannot find any 3 over here. So this is the edge case that we will hit. Okay, so for this, and we can see that we are returning this 3 in the answer, which is wrong. So for this, very important thing is, we'll move from bottom to top. That is, we will first remove all the nodes which are at the lowest, at the most depth. That is we'll move from bottom to up. I'll check whether 4, 8, 9, does these 3 nodes present in this? No, they are not. Does 3, 5, 7, 10, are these present in this? Yes, 3 is present. So now I will remove this 3 and store its. So this is the wrong answer. I'll make another list. Now I'll store the left right subtree of this 3. I have 4. I'll store 4. Now 3 is removed. 3 is removed and the leftover tree looks like this. 7, 8, 9. I have 2 and then 5, right? Now I have removed this 3 from the tree. Now in this level I can see I have 7 and 10. First I'll remove, let's say 7, let's say 10. Okay, so this is removed, there is no subtree, ignore it. For 7, now I'll remove the 7 and store the left right subtrees, that is 8 and 9. Now the left is, now this level is completed. Now tree looks like this: 1, 6, 2 and 5. Now is 5 present in this array? No, it is not. Only 2 is present. Okay, so now I will remove this 2 and store its subtree, that is 5. Now this is the correct answer. So one important thing is we'll use DFS over here. That is, first we will go towards the utmost depth we'll go. Then after going to the utmost depth, that is towards the end of this tree at the lowest level, now we will start removing. Because of this edge case we are doing this. Okay, now we'll write the code. Okay, so in the main function that we have, we only have these two parameters given. That is, the question has provided us with the root of the tree, and another is this integer array of to remove. Okay, here I can see that I'm again and again checking that whether the element present in this to remove array, so it is not ideal or optimized to again and again traverse this entire array. So for that I want another data structure which will give me the answer whether it is present in it in O of one time. So for that I will use set over here. Okay, I'll initialize set with integer type. Set equals to new hash set. This is how we make a set in Java. Now I will store this, all the elements in this to remove array inside this set dot add. I'll do set dot add I. Okay, so all the elements are now stored in this. Now I will make another list. This is the answer which I have to return. The return type of this list should be node. Okay, I'll name it as list equals to new array list. Now I will write the solve function. For that, first I'll just make the function. I'll call this function over here. I'll pass root of the tree, then set of all the elements which I have to remove, all the nodes, and then this list. After that I will return this list. Okay, so this is the main function. Now we'll write the logic, the solve function in the next. Now we'll the return type of this solve function would be node type. I'll tell why node type should be the return type of this. I'll write the name solve, and as I told in the main function, the parameters are node, then we have set of integer, and then this list of node, which is the answer. Okay, now the base case, like what if this root is null? If the root is null, we will return null, because if the root is null, there is nothing to remove. Okay, now next, as I told previously that we'll use DFS. So as we are using DFS, we'll go towards the bottommost. Okay, so going toward to the bottommost, we'll write root dot left, root dot right. Okay, so why am I assigning this? We'll understand this lately. Okay, in further, you can see that I have mentioned here the return type is node. That's why it will assign that root dot left, root dot right. I will call the solve function with root dot left, then rest all same, set and list, solve, root dot right, set, then list. Now here when the code will execute these two lines, now it has reached to the point that is at the last. Now it is at this position. Now it will check that if set dot contains this root dot val, right? If it contains, that means I have to remove this. If I want to remove this, so now what I'll do, what if it has some subtrees, right? So I have to store this in the answer, and for example, if this node has called this, it will return null. That means now its left will become null. As for example, I'll repeat it again. If I have to remove this, I'll store its subtree in this list as answer, and this node will return null. So if this node has called this node, which has to be deleted, it will return null, so its left will become null. That's how it will be removed. Similarly for right as well, right? So if set dot contains root dot val, that means this has to be deleted. First, that if it has a left subtree, if its left is not null, then do list dot add root dot left, right? Root dot left. Similarly for right, if root dot right is not null, store in the list dot add root dot right. Now return null. Okay, now close this parenthesis for this if condition. Now at last we always return root, you know this, return root. Okay, so this is the entire code for this problem. Now we'll do a quick dry run. Okay, now I have drawn the tree for dry run. Here the to remove array is given, that is these nodes are to be deleted, and now I have converted that into a set, you can see. Now let's start this question. Okay, so when I will call this function with root, that is 1, it will come over here. Does 1 null? No, it is not. It will call root dot left. Now pointer will come to this node 2. Now 2 will come over here. It will check, is 2 null? No. Then call left. Now pointer will come over here. Now 3 has come to here. It will check, does 3 null? No, it is not. It will call root dot left. Now it will come over here, right? It will come over here. Now it will check, is 4 null? No, it is not. Call root dot left. Now it will come over here, this null. It will check this root null. Now we have reached null, so it will return null. And we know that root dot left is null. Root dot left, that is 4 dot left. It is already null, no problem. Now it will call root dot right. 4 will call, and this is null. So here we have null. Okay, here we have null on both sides of 4, no problem. Now 4 has executed this line as well as this line. It will check this set contains 4, that is root dot val. No, set does not contain this. Okay, then do nothing, then return root. That means return this 4, return 4. So 3 dot left is 4. It is assigned. Okay, it is assigned. 3 has called this 4, so 3 dot left is 4. 3 dot left is 4. Okay, now 3 will call this root dot right. It is null, so it will return null. 3 dot right would be null. Okay, no problem. it will check does set dot contains 3. No, there is no 3. Then it will return 3. Return 3. What has called 3? 2 has called 3 in its left. So it is 2 dot left is 3. 2 dot left is 3. Okay. Now 2 will call this root dot right, that is 5. Root has called this, 2 has called this root dot right. Now it will come over here again. 5 has come here. Is 5 null? No. 5 dot left, both are null, so it will get null from both sides. 5 will get null from both sides. Okay. Now 5 will check does 5 set has 5. No, there is no 5 in this set. No problem. Return root, that is return 5. So 2 dot right is 5. 2 dot right is 5. Okay. Now it is a call of 2. It will check does set dot contains 2. Is there a 2? Yes, there is a 2. Okay, there is a 2. Then do what? Then does it have a left subtree? Root dot left is not null. It has this. Okay. Then in the array store this 3. Store this 3. We only have to store the root of the subtree, else the compiler will handle. Okay. Root dot right is not null. It contains 5. Similarly add 5. Add 5. Added. Okay. Then return null. Now when 2 will return null, it will go to 1. Now 1 dot left is assigned as null. Now the tree will become like this. Here it is null, that is nothing. Rest all same. Okay, the tree has become like this. Now it has returned null to 1, and we can see that the 1 has called this through this call root dot left. Now 1 will call the right part, that is 1 dot right. It will come over here. We have now will come over here at 6. At 6 we are at 6. Now 6 will call its left. It comes over here at 7. It has reached over here. 7 will call its left. Okay, we'll reach here. Similarly 8 will call left. We have null here. Okay, so it will hit this base case, root equal to null. So similarly for right we have null and null for 8 for both sides. Okay, now 8 has executed these two lines. It will check does set has 8 value. No, there is no 8. Then do what? Skip this. Return 8. Returning 8 means storing 8 in the left of 7. Storing 8 in the left of 7. Okay, now 7 has executed this. 7 will call this 7 dot right. We have 9 here. We can see that 9 has nothing in its left right, so it will return null. Okay, 9 has got null from both left and right. Now 9 will check does 9 is having the set having 9. No, there is no 9. Then skip this. Return 9. It will be assigned to the 7 dot right. Okay, now 7, it has returned 9. 7 has 9 in its right. Now 7 has executed these two lines. It will check does set has 7. Does set has 7? Yes, it has 7 over here. Then do what? Store its left subtree and right subtree. It has 8 in left, 9 in right. So I will store this 8 and 9. After storing 8 and 9, return null. Now 7 will return null to 6. 7 will return null to 6. Okay, now 6 has executed this. Now the tree will become like this. Tree will become like this as we have null from left of 6. Tree will become like this. Okay, now tree is looking like this. Now 6 has executed this. Now 6 will do 6 dot right. We have 10 in its 6 dot right. Okay, now 10 will call root dot left. We have nothing in left, so it will return null. Similarly for right we get null from both left and right. Now it will check the set contains 10. Yes, it has 10. Then store its left and right subtree. There is nothing in left, nothing in right. Don't add anything. Okay. Return null. Now this 10 will return null to 6 over here. Okay. Now tree will become like this. 1 and 6. Now tree is looking like this. Now this has returned to null to 6. 6 has executed this. It will check the set contains 6. No, there is no 6. Do nothing, skip this if condition, return root, that is return 6. Return 6 to 1. Now 1 has got 6 from its right. That means 1 has executed this. It will check the set contains 1. No, there is no 1 over here. Do nothing, return root, that is return 1. It will return 1 and we will complete the recursion call. Now what we get the answer? We'll get the answer like this, and we have checked it previously in the starting that this is the correct answer. So I did a dry run as well as I wrote the entire code. I hope you understand. If you still have any doubt, you can drop it in the comment box, and thank you for watching.